Good afternoon. My name is Al Toby. I'm an evangelist for Apache Cassandra at DataStax. I'm here to talk to you about why shellshock matters to you, even if you're not using Bash as a CGI program or anything like that. So you've heard that it might be remotely exploitable. So my first reaction when I read this was, well, you'd have to have a Bash CGI script, and who's going to do that? Except for a few enterprises that maybe have it behind a firewall. So shellshock kind of looks like this. This is my test exploit. It's just a function that's in an environment variable that gets automatically executed by Bash. So even if you don't think that Bash is involved in your system, sometimes it is. If, for example, you have a Ruby Sinatra application that in one route calls system to execute a program on the command line, if you have any shell meta characters in that command line, it's going to call bin.sh to parse that. And if that's assembling to bin bash, then you're basically vulnerable to shellshock in your Ruby program. And what does that look like? So here's a Perl program that shows vulnerable and not vulnerable configurations for using system. So I'll talk to the code in just a second, but let's run it real quick. So I'm going to run it once without, let me clear it. So this is without shellshock exploit being active, and I have it right here. Here's my function, so let's source that. Let's get it in my environment. We can look at it there. And now when I run this Perl script, the first system call is going to be exploited, and it's going to show invulnerable, and then the second one doesn't. And the way you protect against that is when system executes sh-c, the environment of the parent process is automatically copied to the child process. This isn't something that's built into Unix. It's just that when you launch a process with execve, you have to pass it an environment, I think it's an array of key value pairs. Most things like Perl and Ruby will just copy the parent's environment to the child's environment, which is what you typically want. That's what Bash does. That's what almost everything does. But if you're in a CGI environment or something else where you have external actors able to access the system, you need to be a lot more paranoid. And the way to do that in Perl is to use a local, the %env hash is global in Perl, but you can localize it inside of a block, and that's what I'm doing here. And so this local %env, what I'm doing is setting a whole new hash, overwriting it just inside of this block that I open right here. And then I call the system env. And if we look at this file that I've created, you'll see that there's a minimal environment in there. It looks like Perl or env itself is adding these back, but those are no big deal and pretty safe. But notice that the shellshock variable, even though it's still in my shell, isn't getting passed through. Here's Python. I'm using Python 2 for this just because I have it all set up. Should be the same for Python 3. And it's os.system, which if you're very old school, that's what you would use. Has the same problem as Perl, and that when we execute it, it will pass the environment through. And you see that it's vulnerable. But there is a safe way to do it in Python that's actually a lot cleaner than the Perl way, is to use the subprocess.call method, and we execute the exact same command. I set shell equal true because in this case I do want it to use the shell for sure. Most of the time, if you don't need shell redirects and things, that shell should always be set to false. That way, even if somehow a malicious program or a junior engineer accidentally puts shell meta characters in that string, be it an upstream variable or a configuration file or whatever it is, you don't have to worry about it magically suddenly starting to interject this sh-c between Python and the program you're trying to execute. And then finally, I pass a clean environment as a dictionary to the call method, and that's the environment that gets used. And we can verify that by looking at the little env script that gets generated. Oh, I already copied that. And here is Ruby. So Ruby's system is actually, at a glance, looked like it was going to be similar to subprocess.call, but actually there is no way to make system safe by just passing a static environment through. You could possibly scrub the environment manually, the global environment, and replace it. There may be some other tricks to play, but it's going to get complex. So I'll show you what happens here. And so the first one, just like all the others, is vulnerable. But it turns out even the second one right here, where I'm passing a hash in, is also vulnerable, because what Ruby's doing in this is overlaying the hash you pass over top of the parent process's environment. So it actually doesn't end up wiping out the shellshock environment variable, and it passes through and you are in trouble. If you're running on Ruby, especially 1.9 and up, the kernel.spawn method is actually one of the better APIs I've worked with around spawning and maintaining subprocesses. It has a huge API, but it is very powerful, and it provides a way to actually do this safely. And what that is just like with system, we pass in an environment hash as the first argument, but we also pass in the options hash, which is the third argument, this unset env others set to true, which means it will clear the environment, not use the parent process's environment, and use only the hash that you pass it. And that all works as expected. So this is the way to go in Ruby if you're updating your code. And we can take a look at that environment, nice and clean and small. Finally, I tested Node. I couldn't actually get Node to show the exploit. I'm not sure why. I went digging through the Node source code. I looked at the C++ around the exec call. I looked at the JavaScript, and I didn't see anything where they were explicitly protecting against malicious environment variables. But for whatever reasons, it's not executing when I call things this way. If somebody knows why it's safe, or if it's actually safe, which I'm still not positive about, please hit me on Twitter at ALTOBEY, Altoby on Twitter, and I would love to hear about it. But if we run this program, it doesn't actually, the exploit doesn't fire. It's still there, and I can run the Perl one, and it still does it. I can run a shell script, and it does it. But so Node seems to be safe. That said, this first exec here is still, even though it looks like Node might be protecting you, you're better off going to the second form. I think always, especially if it's in some kind of a web server or something like that where it can be easily exposed, because when you set the environment to just a dictionary that is defined only for that process, you know exactly what environment is being passed to it, and there's nothing that can escape through for whatever reasons, whether somebody's exploiting you through a remote user environment variable, or if junior admins are making mistakes in .profile, or whatever that is. If you do it this way, there's just no chance of being exploited through environment variables, or very little in any case. So we look at this env again. You can see that it does exactly what we want. And so this is the safe option for Node.js for execing shell code, especially with meta characters that end up calling sh-c. Now, you might wonder why SHC is, or how to check whether SHC is being called at all, and there are a couple of different ways to tell. So I have this little Perl program called sleeper.pl. All it does is just go to sleep, but it has a redirect, a useless redirect to a file in /temp, and that's only there just to force Perl into actually calling sh-c. So I'm just going to run that real quick. But what I'm going to do is I'm going to background it with Control-Z real quick. I see that it's vulnerable. And then all I have to do is run ps, or I'm just going to do ps -o args so that you can see all the arguments. And that's just basically showing you, here's my Perl process. This is my shell. This is my Perl process. So this is the Perl interpreter and the script that it's going to read. And here it is calling sh-c. And it gets past this single argument. You don't see the quotes here, but this would be quoted, or it's all coming through as one argument to the shell. And then it's actually finally, the sh is calling sleep5 for me. And so this is actually what it looks like, what the problem is in this sh, on this system actually, it's assembling to bin bash. And this is why it's a problem. Now, if you're on a Debian system, for example, that has switched to Dash, you don't have this problem. If binsh is some other POSIX compliant shell and all of your system scripts are able to run on it, then you're not going to have a problem. And that's why Debian, I think, a large part of it switched to Dash, is it's a smaller code base to audit and to verify there aren't any of these kinds of bugs. The other way to check it is with strace. And if you're a systems administrator and don't use strace today, I highly recommend learning it, as it's one of the most important debugging tools in your arsenal. But there's a really simple way to look at it here. And all I'm going to do is strace -f, because Node and Ruby and a couple others tend to spin up some threads and you might not see what you want to see. And then -e, and we're just going to look specifically for the exec VE system call. And I'm just going to run, let's look at the Perl one real quick. It's the simplest. And so you see it's executing right here is the bin sh -c, and then now you can actually see exactly how it's passing this whole command line through as a single argument. And then you see the shell actually executing env. It's actually, we're not seeing all the open calls and things where it's setting up the redirect here, but that can actually be verified with the sleeper script by looking in proc. But anyway, here's how you do it with strace -f -e exec ve, and then your program, and you will only see when it calls executes programs with exec ve. The other thing to look at, if you're really interested in how shell redirects and things work, and you see this issue and want to take a look around, we'll just use the sleeper again. I'm going to do a pass. Oh, and hey, I left the old one running. You could take a look at, let's just take a look at this PID's file descriptors. And the only reason I'm showing this is, I don't know if everybody knows that the shell redirects aren't passed as arguments to the subprocesses, and it's important to understand this because this is why sh-c gets used everywhere in Unix systems today, is because it's the only sane way to really parse shell code, basically what is arbitrary shell code that might come through a system command. And this is why I recommend never using that stuff when it's avoidable, is the shell is actually doing all these redirects and opening these files and connecting file descriptors, not the Perl script. So if we look at the sleep that's running, it's standard out, which is always fd1, is redirected to this file in /temp. I redirected standard error to dev null, and the standard in is still connected to my pty right here. You can also look at the sh process, and its FDs aren't that interesting. They're still connected to my terminal because who cares? But the interesting one for that one is the command line, and I'm going to use cat in front just because I love all you people who hate that. So what the proc pid command line file has in it is the exact command line array that was passed to exec ve. If you look at the exec ve man page, you can actually see where you have this const char star path, which is the path to the program, and then you have basically a list of arguments that go to it. Well, that's execcl. Here's exec ve. And then the important part is this last part where you can pass an array of env key value pairs. This is where the shellshock gets passed through into subprocesses, say from Perl to sh or from sh to a subprocess. And I've seen some crazy shell scripts in my time that might even be 8 or 9 forks away from actually having a problem, but it eventually fires. So that's what execv looks like, and that's what we're looking for. And the argv array is what ends up in /proc/ pid / command line. So we'll look at that again. And the other one you can look at, and I just thought of this just now, is the env. I think there's an env environ. And it's the same thing. And you can actually, this is the same thing as running env, but you can actually look at the environment that was passed to a running program. If you look at this one, right there is my little exploit being passed through. So if you want to look on a running system, if any of your processes are picking these environment variables up, you can always inject an environment variable, say in the system profile that's harmless, that maybe has a GUI in it or something. Maybe like put like an export foobar equal UID gen, like something like that, right? And then basically now any subprocess that is passing the environment through without scrubbing it is going to have that in there. And that's easily identifiable across these systems. And I could actually just go and grep, if I'm being silly, -l blah proc star environ, and well, as root. So we won't see any because that hasn't been passed through. But if I grep for that, if you're looking for shellshock, you can actually look for it through this method as well. So that's my spiel on shellshock and sh-c in all of the major dynamic languages. Please go and check your code to see where this is happening, and consider switching your default bin.sh to something a lot less complex than bash. Bash is huge, and after a while there are going to be more exploits. It's just a code base that large and old. This is going to, my feeling is this going to, it reminds me an awful lot of the days when we started finding exploits in sendmail and bind and all those things. And bash is really from the same era. I've looked at the code a few times for different projects a few times, and it's pretty scary to me. So I feel like if I was running systems today in production, which I'm not, I have a few behind me right now, but these aren't in production. They're not facing the public. I have my Linode, which actually I'm going to switch to use bin or dash for its default bin.sh instead of bash for exactly this reason. It's a smaller code base, easier to audit, lot less opportunity for these kinds of bugs to slip through, because basically this is all the result of a fancy feature somebody added to bash that isn't part of the Bourne shell. So keep your programs small, keep them simple, and have a good weekend. Thank you.